airplanes, paper airplanes. Some of you maybe get a good result if he helped you make the airplane. He's a product engineer with a key role in a platform.sh account platform and user tool team. He's actually from Serbia, from Pančevo, but he lives in Germany in the last 2 years, since who cares where do you live when you can do a PHP? Yeah, okay. Branislav, it's your time.
Thank you. Thank you. Welcome. This session is going to be about, well, programming. Original idea for it was to be really difficult programming session, and then I had several sessions like this and people hated me. So I decided to make it a little bit easier to digest. So if you're hardcore developers, you're going to hate me. If you're not, I don't know, we're going to see by the end of the presentation. Read this, I'm not going to read it. This is the reason why people hate functional programming, because people are defining things like, well, this, and nobody wants to read or deal with that thing. So, yes, I'm Branislav. I'm initially a Drupal 7 developer, Drupal 8 developer, front-end developer. I speak at conferences, provide support, and yes, originally from Pančevo, currently living in Rheinbach, which is a really small town close to Bonn and Cologne. I'm a husband, I'm a father, I'm a nerd, but enough about me. Who are you? How many people here are like Drupal PHP developers, strictly PHP developers? Okay, let's try into something else. How many managers here? Well, front-end developers. Okay, how many people here tried a language which is not really PHP? Okay, so you're a smart bunch. How many of you tried, well, functional language and loved it? Loved it? Yeah, it doesn't work like that. Yeah. So it's really tough. Once you start in a language, you just continue using it. But thing is, functional languages and functional idea of programming is really old, much older than programming itself. So I want to try to talk about history of programming, which is something that you cannot as easy find on the internet. So, well, you can. So really, think about the time when we didn't have computers and all the smart people who tried to make a computer. So there's this guy. Who knows about this guy? Yeah, Alan Matheson Turing. He's father of a modern computer. He created this idea, this mathematical model called Turing machine, which basically says that if there is a problem that has a solution, Turing machine is going to find that solution. If not, it's going probably to run indefinitely in this vicious circle of something. And his idea of computing was actually interaction of states. So previous presentation here was about states, and yes, that's Turing's idea. Multiple states, and then states, changing states, and all about states, and yeah. His mentor and PhD, well, on a PhD project was Alonzo Church. Who knows about this guy? Not too many people, come on. So he's actually pretty interesting guy because his idea of computing was ridiculously mathematical. So think about complex equations and then interaction of these equations in crazy way, creating easiest possible solution to a problem. But not really. His solutions to problems are terribly complicated, and this entire calculus he invented and he planned to use for computing was called Lambda calculus. And people at universities learn that things. How many people of you heard about Lambda calculus or learned about it? Okay, how many of you know about it? The exit is there. Because I'm going to talk a little bit about Lambda calculus. And this formula is ridiculously simple. The only keywords in Lambda calculus are Lambda and the dot, nothing else. Everything else are variables of sorts. In this particular case, this Lambda function is going to accept one parameter, x, and it is going to respond with x. And it doesn't make too much sense. However, it has a name in functional programming. It's called identity function. So this is PHP version of it, which is not 100% correct. Who knows why? Well, it's named, and Lambda does not deal with named functions. So anonymous version would be something like this, and we have this. It's PHP 5.6. Let's try a little bit more complicated example. In this particular case, you have a function which accepts two parameters, x and y, and returns, well, adds their squares. So it's really nothing special, and it's relatively easy to understand. Who doesn't understand this? Okay, you're great. And of course, PHP version is this, nothing special. And then you can apply a function to an expression. And the expression in this case may be called variable if you want, may be called anything that can be a parameter to a function. So in this particular case, you're going to take y, add it to a function, and function is going to spit out that y, whatever that is. So again, this is identity function, and it looks something like this. This entire process, although relatively simple and, well, I guess easy to understand, is a crucial process in Lambda calculus, and it's called beta reduction. Now, you can, of course, chain lambdas one onto another, which basically means you're going to apply the left function onto the result of the right function. So this example looks something like this. Are you following me right now? How many of you are sleeping? Okay. But Alonzo Church was a crazy guy. So he actually said everything is a function. Even Boolean values are a function. So he defined a function that accepts two parameters and returns the first one as true. So that's his definition or convention of true, and also false. He takes two parameters and returns the second one. That's a definition of false. And he does some crazy things with logical operations as well. So basically, this lambda function represents operation. You're going to take two values, apply them to these and or not or whatever operations, and they're going to spit out the result of them. Do you trust me? Who trusts me here on this? I'm going to try to prove it. So, sorry. So, logical question. What is true and false? What does it return? So, if you take a lambda function, which defines end, and then feed it with true and false, true being P, false being Q, that's going to be substituted, which is actually alpha reduction, if I remember correctly, but maybe I'm not, or maybe I'm wrong, into true, false, true. And then, by definition, and we know in previous example that by definition true is lambda A, B, and returns A, the first thing. So once you replace the first true with a formula, which takes two parameters, false and true, and returns the first one, it's going to be false. So this does not make too much sense, but it works. I don't know if you agree. Who doesn't agree? Okay. He defined also numbers. So natural numbers that do not exist. Natural numbers are also functions. So, by definition, 0 is defined as a function that takes two parameters. A function, any function whatsoever, and a value, any value. And applies this function 0 times onto a value. So this is PHP definition of 0. Does this make sense to you? To whom it doesn't, because it doesn't to me. Yeah. Definition of one is really something similar. Take two function and a value and apply that function once onto a value. So this is PHP version of number one. And number two is defined the same way, so you have sort of, it smells like recursion, doesn't it? So you have a loop internally which applies the function, and yeah, so number of application of the function is equal to a natural number. If you don't trust me, here's an example of summing two numbers. So 1 plus 2, how to calculate that? So basically you have definition of, well, function that represent number one and function that represent number two. You're going to apply one onto another, and you're going to get a result, which is actually 3 executions of function on x, which is correct answer because it's 3. Ridiculous? Yes. It is. But we had that in 1936 because people were like trying to solve the problem of universal computer back in 1936. And this was why one idea how to solve the problem. Thank God we had this guy. Who knows about this guy? Yeah, he has a model name by his name, although he was not like the greatest engineer in the world. His story is pretty interesting because he was born in Hungary as Neumann János, and he moved to Germany. He was a filthy rich guy, he was party maniac. He moved to Germany and wanted to integrate into German society well. So he gave himself a name, Johann von Neumann. Of course, he emigrated from Germany to the United States, when he also changed his name into John von Neumann, but he liked to be called Johnny. He was a party maniac. He was a guy who would organize all the nerds of that time to do something great. So he organized the nerds to create this general purpose computer for the first time in the history. And when you think about it, until then you had computers. You had computers for, I don't know, 200 years earlier. They were doing like all sorts of stuff, but they were all mechanical, they were all focused on one job. He wanted to create universal thing. And his idea about universal thing is von Neumann's model or architecture, and it still lives today. What's important with it? CPU has an input, it has an output, and it has a control unit which actually deals with instructions. It has ALU, which actually deals with like arithmetic and logic and things. And it has memory, and it has only one unified memory, which provides, well, key value store for both instructions and values, variables and stuff. So in this particular case, this starts smelling like states, state of memory, state of values, and linear model of execution. So he invented, well, not he, but he kind of sponsored the invention of machine language, which is the language we still use today, and it didn't really change too much. And it has this beautiful linear execution, easy to understand for machine. It is not as mathematical as church model. In this particular case, you have a loop from 5 to 10. Who knows machine language here? Okay, not too much. And assembly is a little bit, yeah, just human version of machine language. And of course, this is a big problem because you want to be close to business logic. You do not really want to deal with like moving numbers from registers to registers and then invoking addition in LAU and all the crazy things you would do. So we invented higher level programming languages. Who knows which language this is? Basic. Commodore 64. How many of you grew up using Commodore 64? 10, print banner, 20, go to 10, run. Press play on tape, yeah. And of course, although we have this new beautiful language which is actually human readable, it still needs to compile, and it compiles in the same thing you had before BASIC, and that's That's this machine language, which is here represented as assembly, of course. Things got even more complicated. We got new languages, and they are still being internally compiled to the same machine code. And really, that's the linear programming we still today have, even though now we are talking about design patterns and objects and using objects to actually like contain the values creeping we have. It is still being compiled into this stupid machine code. And we all thought, well, a Lambda calculus died. However, it continued living in the academia. People who do not, well, have to be pragmatic, they can actually allow themselves to experiment with something that may not be useful, and they came to the idea that, okay, maybe this actually can be used for certain things. And in recent years, well, the recent years is too bad expression, I guess. This was cooking slowly, but yeah, we got a lot of functional programming languages, which actually have foundation in the same Lambda calculus invented by Church. There's a caveat though. They all compile into Turing's idea, into stateful things, into machine language. So, yeah. And we got these basic concepts of functional programming, which were like built into functional languages, but we could use them in theory in PHP world. One of them being immutability. So it cannot be pragmatically enforced really in PHP. So if you want to have immutable simple variable, you would have to create this crazy class. I don't know if anybody has a better idea to do an immutable variable. No? Nobody? Anybody, please? No. Well, I guess this is the best solution possible. So a function with a class with a getter without a setter. And we also got strict typing, which is not a requirement of functional programming, but it helps, especially if you want to have like a lot of chain functions and you want to combine them together, and you want one function to take an output and add it to another function. If you don't want to be surprised by unpleasant runtime errors, you may want to use strict typing. And of course, in PHP 7, we got strict typing of both parameters and return values, which is awesome. So, yay. Thank you, PHP. You're awesome. And functional programming has this idea of a pure function. So, pure function is a function that sounds almost unusable. Think about referential transparency. Referential transparency actually means that function returns the same result for a same value every time it gets invoked. So one example of is the sign function, which actually always returns 0 for the pi number. Always. It cannot go, well, it cannot do anything else. So really, if a function is referentially transparent, it can actually be replaced with a key value table. Is this okay? Do you follow it? So, okay. So if you can replace it with a key value table, it is referentially transparent, and that's something that's okay. But function has to, in order to be a pure function has to be eliminated of side effects. Now, think about this. You have a user save function, which does one simple thing, and that's saving a user in a database. Side effect is any change of the state outside of the function. In this particular case, you're changing the state of the database. Where is the problem? Problem is that you cannot test this easily. If you want to really function test, well, if you want to unit test this particular function, you would have to either mock the database or just mock the entire function and say, okay, it works. And you have another problem. You could have another problem. If the same function is being executed at the same time, you would have this collision of auto-increment numbers in database, etc. Of course, we solved that by database locking. But this is still a big problem for master-master database, load balancing, Galera, and everything. Who knows what I'm talking about? Yeah, who tried to set up Galera knows precisely what I'm talking about. But this particular example has another problem. So if you're saving a function or saving a user to a database, it's a new user, and you want, of course, to update the user object with the last insert ID of the database. Of course, you cannot do that because then the function would not be pure. Why? Because the state changed in a way that is an external dependency that is uncontrolled, so you cannot really have referential transparency because, well, you have one user object and pass it to the function twice, and it's not going to spit out the same user object. ID would be different. So this is really useless when you think about it, and if you have these kind of limitations on your functions, you cannot do anything. Therefore, monads from the beginning of the story. I'm not going to talk about them because they are like useless in PHP, my personal opinion. But yeah, what monads do is whenever you want to change an external state, you're going to change the state of the monad. And monad can and then wait to the end of the execution of the entire program. And then when you do not depend on the state anymore, external state is just going to run all the changes in external state. I believe that's the way Haskell works. I have no idea. I never tried it, nor I intend to. So, another important concept is higher order functions. Those are functions that can work onto another functions. So think about function that accepts argument, and that argument may be a function, and then the same function may spit out a new function or result or whatever. So these are higher order functions, and they exist in PHP since PHP 4. Or the array, filter, reduce, map thingies are actually working on callbacks. So you can actually have a callback function, feed array filter with it, and it is going to return something. Of course, anonymous functions did not exist in PHP 4, but the array filter did. So this is a higher order function. It just works on another function. And of course, when you think about this, if you want to have a function that is easily being transferred, moved throughout the code, or even changed during the execution, well, you have to treat function in a special way. So, well, functional programming has this idea of first-class functions, which can actually be assigned to variable. In this particular case, in PHP, we have closures or anonymous functions or whatever, and you can assign them to variables and then move them around without problems. So, are you okay with this? Like, logically, would you code like this? Everything, always? Or who wouldn't? Because I wouldn't. Why would I get rid of all those beautiful PHP given superpowers and changing state everywhere? So first big perk of functional programming is testing is made ridiculously simple. So think about unit testing, you don't need it. Why? Because if you have a pure function, if you can rely that for given parameters, it is always going to return the same result, you can just create a table with several parameters and results, and you can create your own test function, which would be terribly complicated, something like this. So basically loop through the table, invoke the function, and see if results are as expected. If not, just die or something. I don't care. So this is okay. This is convenient. I mean, we just learned to run PHP test and unit tests, and yeah, we have this. And caching also. think about caching. Phil Carlton said that, caching, invalidation, and naming things are the hardest things in computer science. And really, that's why we named caching in functional programming Memoization, because why not? It's not the same. And we don't really care about cache invalidation, never, ever. Why? Because for the given parameters, function is always going to return the same response. So I don't care about invalidation. I'm going to use my function, which is called Memoize. And think about this. You have this scary, complicated, but pure function, which is basically impossible, but still, bear with me. And you want to memoize it. You're actually going to wrap it into this memoize function, which in this version only executes the thing and returns, returns it. So we have to update this memoize function by adding some sort of key value store and trying to imagine, okay, what would be the best key for this particular, thing in order to work, because this memoize is not going to work only on one function, but multiple. So you can use function name and parameters as one key. You can hash them if you want, I don't care. But get class function may be a little bit of a problem, especially if you are feeding Memoize with string name of a function, like internal PHP function. And then what you do is just checking if there is not a value in the key value store. If there is not, then you're going to execute this expensive function, add the value into store, and of course return the store. So this is relatively simple way to do a memoization. It's not perfect. If you want to make it perfect, then you would probably feed Redis with it. And then we are talking about changing of states and monads, and I don't want to talk about monads. So somebody said functional programming is all about complexity control. And really, when you think about it, all the boilerplate code I show doesn't really look like it's easy to read. And it gets even scarier. So, I don't know. Complexity control may be just expression people who got used to functional programming use a lot. Anyways, their idea about complexity control is you don't want to deal with things that are not business logic. You want to deal only with business logic and let programming language or library or anything just to deal with the rest. So in this particular case, higher level abstraction, which is something that we strive to, means I don't want to deal with plumbing problems or whatever. I don't want to control every aspect of my program. So who does want to control every aspect of their program? Hands up. Nobody, one person. Even this? I hate it. How many C programmers here? Do you hate this? Well, sometimes. So, I don't want to deal with the stack. I don't want to deal with registers and heap and garbage collection and things. I don't want to deal with it. Therefore, I'm a PHP developer. So the question is, so we abstracted away a lot of hardware. We abstracted away a lot of things, even, we today live in serverless, cloudless, whatever-less society. And what can we abstract away? This is one idea. So loops are not part of the business logic. Think about this. You have a loop which does things on an array, and it is guaranteed that it's going to be a sequential process. If you do something like this, if you use array map, well, it is still guaranteed that it's going to be a sequential process, but if we had better compilers, in theory, we could do something like this, or even something like this. And today we have Apache Hadoop, we have CouchDB, we have Scala, which do these kind of things. They are taking care of parallelization without you thinking about them, or at least with your minimal involvement. PHP does not do that. It could, but even developers of all the black magic involved within this threading thingies say that they do not suggest it. So yeah, who played with threading here? What are your experiences? Don't do it. Yeah, don't do it. So, next slide is terrible and you're going to hate me about it. Rotten Tomatoes, let me see, boo. No? Okay. Design patterns are not business logic, therefore they could be abstracted away. I said should, but maybe could is better. So yeah, I'm going to say something like this. Imagine Decorator Pattern. Who uses it in their projects? Who hates it? Okay. So Decorator Pattern is relatively simple to explain, and it's all about changing the way your class behaves by adding atomic pieces of logic on runtime level. Again, runtime level, not compile level, so it's not inheritance. So if you want to create a pizza thing with mushrooms, mozzarella, and basil, and of course you want to combine toppings for like various flavors and things, you would create a pizza object. Then you will create a new object called mushroom object. Well, mushroom, using mushroom class, and feed it with your previously created pizza object. And then you will continue by creating new mozzarella object and feeding it with mushroom pizza, etc., in order to finally get price of the whole package. So you can actually construct it like this, and you have this kind of crazy construction, big nested construction logic. What are the problems of this approach? Who could tell me, like, right now? What is the type of this pizza? Bad pizza? Basil. Type of my bad pizza is basil. So it's not perfect, but it does the job. So functional programming has this new concept, which may be a little bit easier to understand and implement. It's not as powerful. So I don't know. In this particular case, you want to compose pizza using mushrooms, mozzarella, and basil. And this would be kind of perfect function or perfect way to do it. Is it possible? Well, if you define mushrooms, mozzarella, and basils as functions that modify the price, and then it's just instantiate bad pizza with the initial price, which would be the price of the dough, this could work relatively easy. Of course, we don't have compose function in PHP, which is a problem. And of course, if you even want to update your object, which is on the runtime, you can do it relatively easy, or your function, because now we're talking about functions. You take the bad pizza and add 2 mozzarella, since it's going to be better. So yeah, our problem is boiler code again, or boilerplate code. In this particular case, you need to use the stupid identity function. There's no way around it. And why? Because compose needs to start from somewhere and then slowly loop through all the functions you feed into in order to, reduce functions to one function that does everything. It starts with identity, which is just take the value and return value. So it is a way, identity is a way to, maybe convert values into functions so that you can work with them in functional level. So we have got some libraries that can help us with that. So Lars Stroini developed a functional PHP library, which is pretty awesome because it actually has all the helpers you need to start doing functional programming. Functions are nicely namespaced, so this is the way for you actually to build your pizza using his compose. Relatively simple and looks elegant, looks beautiful. And of course, you don't have to write your own memoization function. You can use his, which also uses static values, so it's not perfect. If you want to make it perfect, refactor it to use I don't know, Redis or something. And of course, it has great support for traversable objects and arrays because that's what functional programming is all about, like looping through things and doing things on those things. So in this particular case, you can evaluate if every single value of a group has some conditions or anyways. You can run all kinds of queries relatively easy with your arrays. And there is a matter of performance because functional code also needs to be converted into machine code, and therefore they're not compatible, mutually compatible. So there is always a loss. Compiler needs to be aware of that. PHP compiler is not. So when you think about running 10 million operations of mapping, filtering, or reducing, you can see that there is a significant difference between using library and like imperative style of programming, which is simply define a loop and loop through it. However, if you start thinking in a functional way, soon you're going to figure out, oh my God, I can parallelize this, and not even by using threads. So this entire story started with this project for Platform SH, the company I work for. I'm actually maintaining this recurring billing system, which is Synchronous, saying on the first of the month, I have to invoice a lot of people. And we have this loop checking the state of the orders, and then charging people, completing orders, creating invoices, emailing the users. Invoices are actually PDF documents, and that loop goes, well, thousands of times during a night. And, you know, it's a lot of time. So when we actually analyze the performance of this entire loop, there is one bottleneck, and that's creating the invoices. Why? Because they're PDF, so we need to generate PDF, and we are using dump PDF, which is not really the greatest library in the world. Who tried that? Who uses dump PDF? Several people. Okay. Do you love it? I don't know. So yeah, it's slow. It's terribly slow, the process, and this entire loop stops because of the slowness. So if you actually detach all the services and add job queues between each of the steps, then you can actually fine-tune, load balance things and allow other things that are not really issuing the invoice to run faster and not to block your server, etc. So this kind of event-driven design makes sense. But really, if issuing the invoice was built in a functional way without using external states to build an invoice, because you feed it with data and it should just spit out the PDF document. You could do something like this, and you could be fairly sure that no race conditions are going to happen there. So who has problems with race conditions in PHP? Not many people. So I thought that's actually impossible until I started working for Platform SH. Now we have a race condition all the time. But you could do something even bigger and more interesting. You could upload a function, which is of course a Lambda function, on the cloud somewhere, and execute it only on demand. So demand, create me an invoice, this is your order data, result, okay, this is the link to download the invoice, or something like that. And this already exists, and it's awesome. Why? Because you're paying for it only when you're using it. But not only that, when you're using it, and when you're using it a lot, they're going to scale it and make several instances of containers running your scripts. When you're not using it, they're going to kill all the instances. Thing is, it has stupid name, serverless, and it exists with AWS, with Google, with Microsoft, IBM. It works. It executes functions on events, it executes them on HTTP requests, and you can even chain it with automatic upload to S3, where, well, people can download the invoices there. So it works. Are you all supposed to become functional programmers immediately? No. PHP is not a functional language. PHP just became amazing object-oriented language, and we do not want to, we don't want to change it from the scratch. Actually, when you think about it, most of the libraries are not functional. They are totally stateful, and they are totally messing everything. So you really want to continue using all those wonderful libraries. PHP may be used between others for functional programming, but really it is general purpose language, and it should be treated like that, without leaning to one on another side. However, when you think about just think about postulates of functional programming. You could use it pretty nice with your object-oriented code, and if you control your states, and that's really important, control your state-changing functions, do not, run state changing everywhere. Who knows Drupal here? Drupal? No. So basically, Drupal has this idea of hooks. You create an object, and then you have ability for functions to process that object in most magical way ever. So you loaded the user, and you have some data in the database, but your result is totally different user object because on multiple places your application changed values of that object, and you have no idea why. So it's an anti-pattern because you need to debug it once it goes wrong. But yeah, not necessarily by using monads, and it's terrible. Thank you.
Do you have any questions for Branislav? Any questions? I've got the mic. I just need a hand up so I can give you the mic and you can ask the question.
Rotten Tomatoes?
No? Okay, this is how we're going to do it. You can ask Branislav anything in the lunchtime, since this is the last lecture, and we're going to see you here sharp 14:30. Lunchtime starts at 13:00. I hope you had a nice time. See you here 14:30. Thank you.